दिसत आहे. ओके. तर आपण गुगल क्लासरूम वरती कोऑर्डिनेशन केमिस्ट्री एक टॉपिक संपवलाय. तो टॉपिक तुमचा ऑर्गॅनिक इनऑर्गॅनिक केमिस्ट्रीच्या पेपर मध्ये होता. आज आपण दुसरा एक टॉपिक सुरू करूयात, मेटल कार्बोनिल्स. ओके. हा टॉपिक तुमचा फिजिकल इनऑर्गॅनिक केमिस्ट्री मध्ये त्या पेपर मध्ये आहे. सो मेटल कार्बोनिल्स. What are metal carbonyls? These metal carbonyls are the coordination compounds, one type of coordination compounds in which the transition metals has forming the coordination compounds with carbon monoxide. Here the ligand is carbon monoxide. मेटल कार्बोनिल्स मध्ये मेटल कार्बोनिल्स एक प्रकारचे कोऑर्डिनेशन कंपाऊंड्स आहेत, कॉम्प्लेक्सेस आहेत आणि त्याच्यामध्ये लिगँड कोणता आहे? कार्बन मोनॉक्साईड. ओके. तुम्हाला आवाज कोणाला येत नसेल, क्लिअर दिसत नसेल तर मला सांगा मध्येच. ओके. Then the carbon atom of carbon monoxide donate lone pair of electron to transition metal under suitable conditions. In this metal carbonyls, carbon monoxide molecule, the carbon of that carbon monoxide molecule is donating lone pair to the metal ion. One more peculiar, or we may say the difference between simple metal complexes and metal carbonyl is that in metal carbonyls, the oxidation state of metal is either 0 or its lowest possible value. In coordination complex, metals are in some oxidation state. Simple coordination complex मध्ये काय असतो? मेटल कुठल्या ना कुठल्या ऑक्सिडेशन स्टेट मध्ये असतो. पण मेटल कार्बोनिल्स मध्ये मेटलची ऑक्सिडेशन स्टेट एकतर 0 असेल किंवा लोवेस्ट पॉसिबल ऑक्सिडेशन स्टेट असेल. जी काही लोवेस्ट असेल स्टेट ती ऑक्सिडेशन स्टेट असेल मेटलची. ओके. सो these metal carbonyls serve as precursors for the preparation of other organometallic complexes. ऑर्गॅनोमेटॅलिक कंपाऊंड सिंथसाइज करण्यासाठी आपण हे मेटल कार्बोनिल्स वापरू शकतो. तर मेटल कार्बोनिल्सचा जनरल फॉर्म्युला काय असतो? Mx टाइम्स COY टाइम्स. M मीन्स मेटल, X मेटल असतील आणि Y कार्बन मोनॉक्साइड लिगँड्स असतील. ओके. M is a transition metal and CO is carbon monoxide. X and Y are integer numbers. So what we have seen, the metal carbonyls are coordination complexes of transition metals and the ligand in this is the carbon monoxide. We know the carbon atom of carbon monoxide has lone pair and that carbon is donating lone pair to the metal atom under suitable condition. Okay, we see here metal atom because in metal carbonyls metal is in 0 oxidation state or its lowest possible oxidation state. That's why we call it as a metal atom. So the carbon of carbon monoxide is donating lone pair to the metal atom and such compounds are called as the metal carbonyls. These are denoted by the general formula Mx times COY times. These metal carbonyls are classified depending upon the number of metal atoms per molecule. We say mononuclear carbonyls or mononuclear metal carbonyls. In these metal carbonyls, what happens? There is only one metal atom per molecule. There is only one metal atom and the carbon monoxide ligands were attached to that metal atom. So we may write here Mx means M simple and COY times. Example of such carbonyls is nickel tetracarbonyl, iron pentacarbonyl, chromium hexacarbonyl, etc. These are the examples of mononuclear metal carbonyls. In this mononuclear metal carbonyls, there is only one metal atom per molecule of this metal carbonyl. Okay. The metal atom having even atomic numbers can form mononuclear metal carbonyls. So which metals can form mononuclear metal carbonyls? The metal atoms which has even atomic number, they can form mononuclear metal carbonyls. These mononuclear metal carbonyls are soluble in organic solvents like ether, benzene, etc. These are insoluble in water. So these mononuclear metal carbonyls, properties of these mononuclear metal carbonyls are, these are soluble in organic solvents like ether, benzene, etc. And these mononuclear carbonyls undergoes vaporization without decomposition. Mononuclear metal carbonyls undergoes vaporization without decomposition. They cannot decompose. They can convert into vapors. So these are volatile in nature. Mononuclear metal carbonyls are volatile in nature. They evaporate. Their vapor pressure is very low, so they can evaporate easily. Second class is polynuclear metal carbonyls. These polynuclear carbonyls contain more than one metal atoms per molecule. पॉलिन्यूक्लिअर मेटल कार्बोनिल्स मध्ये काय असतो एकापेक्षा जास्त मेटल ॲटम्स असतात. फर्दर दिस पॉलिन्यूक्लिअर मेटल कार्बोनिल्स वी मे से डायन्यूक्लिअर ट्रायन्यूक्लिअर टेट्रान्यूक्लिअर एक्सेट्रा. दोन मेटल असतील एका मॉलिक्यूल मध्ये तर डायन्यूक्लिअर, तीन असतील तर ट्रायन्यूक्लिअर एक्सेट्रा. So in this there are more than one metal atoms per molecule. Their general formula can be written as MXCOY times. X can be 2, 3, 4, 5, etc. Okay, and the Y may be any integer number. These polynuclear carbonyls may be homonuclear or heteronuclear. These two metal atoms may be same metals or may be different metals. If these two metals are same metals, then these are called as homonuclear metal carbonyls because both metals are same. If the metal atoms are different, then they are called as heteronuclear metal carbonyls. For example, homonuclear metal carbonyl is Fe3CO12 because all three metal atoms are Fe atoms. And the heteronuclear metal carbonyl is MnCO CO9 times. In this, there are two metal atoms, but these two are different. One is manganese and another is cobalt. So we call it as heteronuclear metal carbonyls. And this is called homonuclear metal carbonyls because all metal atoms present in one molecule are the same. And here these two metal atoms are different. Okay. So these polynuclear metal carbonyls are soluble in organic solvents just like mononuclear. These polynuclear metal carbonyls undergoes decomposition below their melting points. They cannot melt. If we heat these metal carbonyls, they get decomposed into respective metal and carbon monoxide. They instead of undergoing melting, changing state from solid to liquid, they undergo decomposition. But the mononuclear metal carbonyls were not going decomposition. They are converted into vapor state. Okay. So these are the properties of these mononuclear and polynuclear metal carbonyls. Okay. Now we have to see one nickel tetracarbonyl metal carbonyl. It is a mononuclear metal carbonyl, nickel tetracarbonyl. We have to see its preparation, its reactions, structure, etc. for this metal carbonyl. Okay. So the nickel tetracarbonyl is first metal carbonyl synthesized by Mond in 1890. In this metal carbonyl, nickel is a metal central metal atom, and there are four carbonyl ligands. There are four carbonyl ligands in nickel tetracarbonyl, and the second is the metal atom is the nickel. So nickel tetracarbonyl is the carbonyl of nickel, is a complex of nickel with carbon monoxide. In this, the oxidation state of nickel is zero. It is not oxidized. Means here it is nickel neutral. It is not nickel plus 2. Okay. Its properties, it is colorless liquid. Nickel tetracarbonyl is colorless liquid having melting point 23 degrees Celsius. Room temperature is quite higher than 23. So at room temperature, it is a liquid. It is colorless and its boiling point is 43 degrees Celsius. Just we have seen the properties of mononuclear metal carbonyls. Mononuclear metal carbonyls can be converted to vapor state without decomposition. So this metal carbonyl can be converted into vapor state, and in vapor state it does not decompose. Okay. This nickel tetracarbonyl is toxic in nature. It is very toxic in nature and having musty smell. This nickel tetracarbonyl has musty smell. Methods of preparation, how nickel tetracarbonyl is prepared. One method is given, that is called direct method. In this method, by the action of carbon monoxide and on reduced nickel at 30 to 35 degrees Celsius, when carbon monoxide is passed over reduced nickel. What is mean reduced nickel? Means nickel in its zero oxidation state. In any compound, say nickel chloride, NiCN2. In this, nickel is in +2 oxidation state. It is oxidized. In any nickel carbonate, any compounds of nickel, any salt of nickel, that nickel is oxidized in +2 oxidation state. But we require nickel atom, that is reduced nickel. So by the action of this reduced nickel carbon monoxide on this reduced nickel at 30 to 35 degrees Celsius, we get nickel tetracarbonyl. This is one method for the synthesis of nickel tetracarbonyl. It is called direct method of synthesis. The second method is from nickel iodide. So nickel tetracarbonyl can be prepared from nickel iodide with carbon monoxide, heating nickel iodide with carbon monoxide in presence of some halogen acceptor. This is nickel iodide, Ni2. In this, nickel is in +2 oxidation state and there are two iodine which are in negatively charged. When these are heated with carbon monoxide, we get nickel tetracarbonyl and iodine molecule, I2. Third method is the carbon monoxide is passed over the iron carbonyl halide and nickel hexamine cation to obtain nickel tetracarbonyl. This is nickel hexamine cation, NiNH3 6 times. This pair has +2 charge. We have seen in coordination chemistry. And this is FeCO4 times H twice. This has two negative charges. This complex, Fe complex, has two negative charges, and this nickel hexamine complex has two positive charges. Okay. When this complex is heated with carbon monoxide, sorry, when this is heated with carbon monoxide, we get such type of complex, nickel tetracarbonyl and this FeCO4 times H twice plus 6 molecules of NH3. This NH3 gets replaced by carbon monoxide. Amine of this ligand gets replaced by carbon monoxide. And when this is heated, then again we get Fe3CO12 plus 3 NiCO4. So this method can be used for the preparation of Fe3CO12. It is called iron carbonyl, polynuclear metal carbonyl. Okay. The fourth method is from nickel salt, nickel sulfide or nickel cyanide. It is the nickel salts. Okay. So when these nickel salts were allowed to react with carbon monoxide in an alkaline medium, nickel sulfide is allowed to react with carbon monoxide. We get nickel carbonyl plus sulfur. Similarly, nickel cyanide also, when it is allowed to react with carbon monoxide, we get nickel carbonyl and cyanide. These are the four methods for the synthesis of nickel tetracarbonyl. Everyone is able to hear my voice? आवाज येतोय सगळ्यांना?
हो येते सर.
हा, समजत नसेल, आवाज येत नसेल तर मला सांगा, तिथंच आपण पुन्हा हे करू. Oh, so these are the four methods for the synthesis of nickel tetracarbonyl. Now we have to see its properties. Nickel tetracarbonyl is a colorless liquid, just we have seen. Its melting point is -23 degrees Celsius and boiling point is 43 degrees Celsius. It is soluble in organic solvents but insoluble in water. These are the physical properties. Its state, it is colorless liquid. Melting point, boiling point, these are the physical properties. Solubility is also a physical property. These are the physical properties of nickel tetracarbonyls. These are the, now we have to see the chemical properties. These are just, I have shown these are the all chemical properties in one slide. Okay. So I think our time is completed. It is 11:37 now, and okay, up to 11:50 we may continue. So these are the chemical reactions. जस्ट मी तुम्हाला म्हणतो ना नोट्स कशा असाव्यात, तर नोट्स अशा असाव्यात. ह्या एका स्लाइडमध्ये तुमच्या अर्ध्या पेजवरती निकेल टेट्रा कार्बोनिलच्या सगळ्या रिॲक्शन्स कव्हर होतात. अशा नसाव्यात. आपण म्हणलं ही एक रिॲक्शन आहे निकेल टेट्रा कार्बोनिल ऍक्शन ऑफ हीट. ठीक आहे. When nickel tetracarbonyl is heated up to 100 to 180 degrees Celsius, it decomposes into nickel and carbon monoxide. We may write this in sentence also. When how to write? When a nickel tetracarbonyl is heated up to 100 to 180 degrees Celsius, then it decomposes to nickel and carbonyl. Then we may write such reaction nickel tetracarbonyl, then arrow, then sign of heat, temperature, and then product. It will require more space if we write such. आपण जर असं लिहिलं तर त्याला खूप स्पेस लागेल आणि तुम्हाला लक्षात पण खूप ठेवावं लागेल. बरोबर. तर हे अशा पद्धतीनं फर्स्ट रिॲक्शन ऍक्शन ऑफ हीट nickel tetracarbonyl when heated to 100 to 180 degrees Celsius we get nickel plus 4 carbonyls, means it decomposes. Then the second is action of HCl in gaseous state. HCl this is the example of halogen acid. It is called halogen acid. HCl, HBr, HI, HF. These are called as halogen acids. Okay. So the HCl in gaseous state, when allowed to react with nickel tetracarbonyl, what we get? We get nickel chloride. We get nickel chloride. Nickel tetracarbonyl is converted into nickel chloride plus 4 CO plus H2. One hydrogen molecule, 4 CO molecules, and one nickel chloride. Okay. This is the reaction of nickel tetracarbonyl with H2SO4 sulfuric acid. Same reaction we get salt. This is nickel sulfate plus hydrogen gas plus 4 CO carbon monoxide. This is the reaction of nickel tetracarbonyl with halogen chlorine. With halogen, it gets nickel chloride plus 4 CO. In place of chloride, there may be bromide, there may be iodide, then such reaction will happen. Then the reaction with barium hydroxide, we get nickel carbonyl plus barium oxide. H2 nickel carbonyl. One carbonyl gets replaced by H2. Okay. Then this is reaction of nitrogen oxide. The nitrosyl carbonyl gets replaced by nitrosyl and hydroxide. We get 8 CO2 molecules of nickel tetracarbonyl reacts with this and we get 2 NiNOOH plus 8 carbonyl plus H2. This is the reaction with nitrogen oxide 4. Simple. It is aqueous with water. Nitrogen oxide with water, and this is anhydrous nitrogen oxide. In this anhydrous nitrogen oxide, we get NiNO2 plus 4CO plus N2 nitrous oxide. Okay. Then this is the reaction with the isocyanate CNR. Then the carbonyl gets replaced by this isocyanate CNR groups, and we get Ni CNR 4 times and carbonyls. With PCl3 also carbonyls gets replaced with PCl3. With NO2 also carbonyl gets replaced by NO2. All these in one slide. How many reactions we have completed? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 reactions we have completed in this one slide. So for your study purpose also, if we write such type of reactions, then if these are easy to remember, you require less space, also less study. But one condition is that you are able to make sentences. तुम्हाला लिहिता आलं पाहिजे ही रिॲक्शन बघून. ओके. फॉर एक्झाम्पल दिस रिॲक्शन विथ NO2 nitrogen oxide. Nickel tetracarbonyl reacts with nitrogen oxide and 4 CO gets replaced by 2 NO2 and we get NiNO2 twice plus 4 CO. That we have to, you may able to write this and then you have to write the reaction also. Okay. So I think we will stop here. Some we will stop here, and the remaining part we will see tomorrow. Tomorrow there will be lecture on 11:10. उद्या सुद्धा आपलं लेक्चर आहे, आणि केव्हा आहे? 11:10 तुम्हाला मी नोटिफिकेशन टाकतो, शेड्यूल टाकतो, आणि व्हॉट्सअपवर पण लिंक टाकतो. ओके.